All right. Hello, everyone. Thank you for joining us today for this week's session of the Parks College Weekly Webinar Series. My name is Amy Price, and I'm the Outreach Coordinator here at Parks College. I'll be joined today virtually by Dr. Tamilselvan and Mr. Spector in the ASAPE lab and CFI's Jason and Donny in our CRJ lab, who will be talking about aviation science spaces at Parks College. We are so excited to have you joining us today from wherever you are. Thanks for taking the time to virtually visit us and learn more about the aviation programs at St. Louis University. In total, Parks College has programs available in aerospace, biomedical, civil, computer, and electrical engineering, and mechanical engineering, as well as flight science and aviation management and physics. We hope that you'll hear or see something today that piques your interest. Before we start, I wanted to give you an idea of how the webinar will flow. In just a moment, I'll be introducing Donny and Jason, who will begin a tour of the Canadair Regional Jet Simulator. Then we'll take a quick question and answer session with the two of them before moving to the ASAPE lab for a tour and demo with Dr. Tamilselvan and graduate student Dave. We will conclude the webinar with another Q&A segment after that tour. Throughout the webinar, we do encourage you to submit your questions you may have to that Q&A feature that's at the bottom of your screen if you're viewing through Zoom, or in the comment section if you're viewing through Facebook Live, and we'll do our best to answer as many questions as possible during the webinar. Throughout this webinar, you don't need to worry about turning off your microphone or camera. You can hear and see our presenters throughout the webinar, but we cannot hear or see you. Finally, if you have any technical difficulties during the webinar, please send an email to parksevents@slu.edu and we'll help address any issues that may arise. This session will be recorded and posted to our YouTube page in the next day or two, and you'll receive an email with that link when it becomes available. If you would like to view any of the webinars from the fall 2020 semester or any recorded webinars we've done so far this spring, you will also find those on our YouTube page. So now, with that housekeeping out of the way, I'm happy to introduce SLU's Aviation Science Department, first with a visit to the CRJ lab. So Donny and Jason, I will hand it over to you now.
Thanks, Amy. Hey, everybody. This is our, I don't know if you can see it, this is our CRJ simulator. So CRJ 700 is how it's set up. I'm going to turn the lights off here so you guys can get a better view of the cockpit. We've got Jason in there. He's going to start the engines and kind of show you how it works a little bit. So this will be a junior senior level course, basically. As we step in here, you can see the instructor station. So this is where we kind of control the environment and the scenarios that happen. And then here's the actual flight deck itself. Say hi to the camera, Jason. So what you can see here, we've got a few different screens. We've got ICUS displays. Primary flight, ICUS displays in the middle for the engine instruments, a primary multifunction flight display on Jason's side, and then obviously also on the co-pilot side. Here in the center stack, we've got things like throttles and radios and nav radios, essentially all the switches to get the airplane running. And then up above in the overhead panel, we've got fuel information, bleed air information, air conditioning, that sort of stuff. So Jason's gonna get it going. You can maybe see some lights and stuff turn on, just getting the engine started. So currently the APU, or auxiliary power unit's running, and that's where we're going to get the bleed air that's required to get the engine started. We can see gauges here in the center are actually what are spooling up as those engines get going. I introduce fuel to it right now. And now you see the first turbine fan stage. Cool. Starter still engaged up top. And once it stabilizes around like 40% power, it'll be So yeah, essentially this is going to be, flying in this is going to be sort of a capstone level course for us towards the end of your flying career with a flight science degree. You'll learn basically how line operations work, how to get a regional jet going, how to get from the gate. As you can see out here, we're actually holding short of a runway at Atlanta, runway 27. And Jason's got those engines running. Just to mention, this cockpit is actually representative of exactly what you're going to see at a, I would say, first or second job coming into the industry. So it's actually pretty similar to what you would be training on.
if you were to get hired by a regional airline. Everything's pretty much represented here, albeit not everything, but most things. So it is pretty accurate representation of what you're going to find in most regional airline operations. And this is one of the most common types of aircraft flown by regional airlines. So it is a good experience. Get you kind of touching some knobs and stuff. But
yeah, it's pretty widely used platform. And one of the biggest training functions is this box right here. We've got the flight management computer or flight management system, the FMS, and it kind of doesn't really work in an intuitive and all that intuitive manner like you'd normally expect. It pretty much works exactly like a FMS. And that's pretty much for route information, navigation information, stuff like that, passenger information, all that goes. So actually learning how to use that is going to be a big, kind of a big benefit of this sim. I think Jason's going to show us a takeoff here.
let's see if I can do it.
We'll see if he can get it going. And then after that, we'll kind of turn it over for questions. Again, not too many moving parts in the sim, but it is pretty cool what we can do here.
I have to really give it more power than I think I did.
So as you can see, the visuals are pretty darn cool.
There's Atlanta. Let's see if I can not run it off the end of the runway.
Please don't. All right, and we're moving. So, and then back here, like I said, the instructor at the station can control things like weather or failures up front, engine failures, instrument failures, engine fires. So we'll let him take off and we'll turn it over for questions.
Some lighting. There we go. 120. Let's just call it one.
Now, normally you'd see the pilot would be flying down the center of the runway, but Jason's showing you
Not so
a left side of the engine or left side of the runway takeoff. All right, that's kind of it. I am happy to turn it over for questions.
Yeah, I'll join. I'll come back out and join you guys. Jason, nice takeoff, nicely done.
That could have been better.
So this simulator I think is so interesting. We've of course visited the parks hangar and seen the simulators there, which are for smaller aircraft, for our training aircraft. And typically during a flight student's career in college, they will be flying small aircraft. This simulator is for a regional jet. So, part of the training process is flying with the idea that there are passengers behind you. And then also students don't learn in the simulator alone, correct?
Ground school course that teaches them more about the operational side of it in terms of the procedures they're going to be following and the systems actually running behind the scenes of this airplane. An airplane like this is going to require specific training for each, type of aircraft this size. So that ground school course kind of gets you prepared to even step in here and know what you're looking at. So it does accompany with the flying course, also comes with a ground school course, and that's how it works mostly in all of our courses here. So
yeah. So with anything, actually, you'd expect the flying the airplane part to be the most difficult to learn, but honestly, that's kind of the easy part. It's the other stuff, the procedures, you're working with a crew, you're learning procedures for your company, stuff like that takes a lot of time and effort to study and learn, and that would all happen outside of the simulator in the classroom.
Gotcha. Yeah, that's what I really wanted to focus on. Is a lot of students learn their communication in the cockpit skills, from one pilot to another in the simulator. And then this is really when students get to practice their team resource management, or TRM, correct?
Yeah, absolutely. So out at the flight line at the airport, we saw, like you said, last week, we saw our sort of general aviation type airplanes where you're learning the basics of flying. And then that doesn't really change across airplanes, right? You move the yoke the same ways, you move the rudder pedals in the same ways. So the foundation is there in these small planes, but then when we get to something that's more complicated, faster, flies higher, does all that stuff, that might require two people, and those two people really have to act as a single kind of cohesive unit. And this is sort of where they get their first taste of something like that, where you couldn't really physically even fly this airplane by yourself. I mean, Jason's doing it right now, but
I'm not doing half the stuff you need to do.
There's not Jason's not doing half the stuff that needs to be done with the radios and navigation and all the other side of things. So So a crew is really required to operate this aircraft in a safe and timely manner.
Excellent.
That's sort of where they learn that.
Perfect. And then, so yes, you mentioned that the configuration of the simulator is very similar to regional jets that would typically be the first airline job that pilots would go into. But, you know, our students don't graduate and then start learning at an airline right away, correct? Can you explain what happens between the time that they are learning in the simulator and then when they actually get into a regional jet itself?
Well, yeah, absolutely. So traditionally with a flight program that's not associated with a university, you would have to, what is it, 2,000 hours, right?
1,500.
Or 1,500 hours. You'd have to log 1,500 hours before you could actually be eligible for application for your ATP and going into the airlines. The good thing about coming to St. Louis U and going through our flight program is that we have reduced ATP minimums, meaning you don't actually, you know, flat out coming out of this program, you don't actually have to log as many hours to then move on to the airlines. We have reduced minimums.
And it's not just the airlines that require that. I mean, basically any jet flying job is going to want to see an ATP, and that's just something that Congress changed back in 2012 as a result of a rather nasty accident. So coming through a flight program reduces those minimums a little bit more, but you do still have to log that time doing something. Some people log the time, you know, doing parachuting operations. Most people will log the time being a flight instructor for a while. And that's probably one of the better routes to go, in addition to the fact that SLU has a CFI program that would allow you to start essentially logging that time the day you graduate. So we kind of set our graduates up really, really well to start building that time that they need to apply for their ATP and then go into the airlines.
Excellent. All right, I'm going to check really quick and make sure we don't have any other questions that came in for you both. And it looks good. Okay, so thank you both, Jason and Donnie, for showing us the CRJ lab at Parks College. And I think Donnie's going to show us where we are headed next. So you guys are actually in our McDonnell Douglas Hall building that is on our St. Louis University campus in St. Louis.
Yep, and then we're going to walk right down the hall here, and we're going to go down the hall, and we're going to go into the ASAPE lab, and I will hand you off to those guys. So here they are, and I think he's going to switch over to their camera.
All right, thanks again, Donnie. See you later.
Thank you. See ya.
All right, Dr. Tamilselvan, I'll let you take it from here.
Thank you. Good afternoon, everyone. I hope you are doing very well today. So I'm Crj Tamilselvan from Department of Aviation Science, St. Louis University. So today I would like to get you a tour on ASAPE lab. It's ASAPE, that stands for Aviation Safety, Aviation Physiology, and Ergonomics lab. So here in our lab, we focus on 3 areas of research. The first area, it's pilot selection, training, and retention, where we try to investigate pilot shortage issue in commercial aviation industry. And also we are interested in studying the dynamics between flight instructors and students. So how they interact in the cockpit and how they tackle emergencies together. So you saw in the CRJ lab that pilots and co-pilots, they were maintaining interactions. So we are interested in studying the dynamics and relationships and interactions that flight instructors and students, they maintain when they are in the cockpit flying together. And the second area is aviation physiology. So in that area, we try to study the pilot's ability to tackle emergencies like bird strike, adverse weather situations, and hypoxia. So whenever the pilots, they're encountering emergencies, they will have certain physiological changes, behavioral changes, and also cognitive changes. So there are like some measures physiologically they change, and they think differently when they tackle emergencies together. So we try to observe all these metrics, physiological, behavioral, and cognitive metrics using different types of sensors, which I'm going to show you today. And the last area is aviation safety. Aviation safety is a key element in the aviation industry. You can talk to any safety, any aviation professional. They cannot stress enough how important safety is. So that's why at universities, schools, airlines, everywhere they emphasize safety. And in safety, we are particularly interested in studying the relationship between increase in automation and with decrease in manual flying skills among pilots. So you have seen the same thing with the Boeing 737 accidents where the automation it overpowered the pilots. The pilots, they were not able to tackle that when they are on board. So these are the areas we are considering and we are studying right now. And this is a simulator setup that we have. So this is a single-seater simulator, and this is designed exclusively for research. This is not for training purposes. That's why you don't see two seats here, one for pilot and one for co-pilot. This is totally for research. And this simulator is LI PI 1000 professional flight simulator. And this is a FAA-approved training device. And you can switch different configurations like single engine or multi-engine. And also you can practice sessions like Cessna or Diamond models. And also you can practice in a wide variety of airports. You can practice in JFK or Orlando or Chicago, anywhere. You can practice your sessions. And this is Dave, our lab research assistant. And he's gonna fly. And he is wearing 3 different sensors today. So the first one is eye tracking sensor. That it looks like regular eyeglasses. So with that, we are trying to see how the pilots, they are maintaining visual attention during flight. So with this, it has high fidelity cameras on it. So with that, we will be able to know the pilots where they are looking at, how long they are looking at, how many times they are looking at, whether they are blinking more, whether their pupil tends to dilate more. So with that, we'll be able to know if the pilots, if they are blinking more, then they are anxious, they are stressed if you're putting them in an emergency situation. And also, there are chances that pilots, they didn't get enough sleep the night before. So these are the things that we continue to investigate. And the second one is a galvanic skin response sensor. So this is a sensor we observe changes from the skin. So whenever the pilots, they feel anxious or stressed, they used to emit certain secretions, and these sensors, they should be able to capture all those different physiological changes. And the last one is pulse oximeter. So it's a regular pulse oximeter that you see that's very common among people. So with that, we are recording heart rate and oxygen saturation. So these are the 3 sensors that we do have right now, but in future we are planning to integrate EEG as well. With that, we'll be recording mental workload and any type of cognitive changes that the pilots, they experience while they are in the cockpit. Cognitive changes in the sense how they are thinking. Whenever they are in emergency situations, the signals in the different brain lobes, it tends to differ. So we'll be capturing all those signals. So Dave, he's gonna fly, and we will see how these sensors capture all the signals with eye tracking, with pulse oximeter, and also with galvanic skin response sensor. So he's taking off now from St. Louis Downtown Airport. And this is the instructor station. So I'll be able to reposition him on a takeoff position, or I can introduce certain failures like engine failure or airspeed indicator failure, any type of failure I can introduce. And those are like emergencies. And with that, the signals tends to peak, or it will be in a wavy form. And while Dave is flying here, I'll be monitoring all the signals in the instructor station here. Sorry about that, got locked out. So here we'll be monitoring all the signals. And this is a signal from the eye tracking glasses. So it has high fidelity camera in it. And I'll be able to see Dave, where he's looking at and how long he's looking at and all those types of data. With that, we are monitoring how the pilots, they are maintaining visual attention during flight. And it will provide deeper insights into the human factor issues that they experience while they're in the cockpit, while they're experiencing emergencies. And this is a window where we'll be monitoring all the signals together. So these are the cool things that we are working here. And also we are planning to run different studies. And when you're here on campus, if you want to get involved in research, just reach out to us, and we'll be happy to get you involved in our lab activities. Thank you for listening. And if you have any questions, I'll be happy to answer.
Yes, thank you both for this really fascinating demo and introducing us to kind of the world of aviation research. So as Dr. Tamilselvan said, if you have any questions, please submit those to the Q&A feature or to the comment section on Facebook. I wonder if we can have just really quick conversation, because hopefully the impression that our viewers are getting is that aviation research focuses a lot on the human, and you mentioned human factors and kind of the limitations of the human body. And one thing that you talked about was hypoxia. And for anyone interested in aviation, you're going to hear about hypoxia a lot and the threats of hypoxia. So Dr. Tamilselvan, could you just talk us through what is hypoxia, what's going on, and why is that such a dangerous threat for pilots?
Yes, thank you. So hypoxia is a medical condition where pilots, they experience reduced oxygenation in their blood and in their body tissues. So if you are experiencing reduced oxygenation, then you will pass out in just a minute. The oxygen will trap out very fast and you will pass out very soon. So that's why most of the airline manufacturers, they will have test pilots to go through hypoxia training, and also commercial pilots, military pilots, especially Navy. You will be seeing instances maybe a couple of years ago, there are like a lot of grounding incidents that happened with Navy fighter pilots. So those are all due to hypoxia. They were experiencing episodes of hypoxia while they were about 40,000, 50,000 feet. But among student training, they're not very much focused on hypoxia training. So whenever they get into industry or whenever they get into military, they go through that type of training. I feel like it's a necessary aspect that students should experience while they are in flight school, because it's physiological changes. You don't know how your body will respond when you're experiencing those emergencies. That's why it's a key, and we are trying to bring that normobaric chamber on campus so that our students, and also we will invite the local community to come here and get that type of training. Because so the hypoxia chamber, it's a special chamber, and it needs certain medical professionals to maintain that type of environment. So you can reduce the altitude, you can reduce the pressure, and also you can vary temperature. So with that, you can simulate the entire environment that you will be experiencing above 60,000 feet. And in that, you will be wearing oxygenation mask and everything, and go through that type of training. And there is a training facility with FAA in Oklahoma City where most of the pilots, they go yearly to get that certified. Most of the fighter pilots with Air Force, Navy, FAA, testing pilots, all of them, they go through that academy to get some type of training. But I feel as students, they should get at least 50% of what they are going to see in the industry. So that's why we are trying to get all these running in our lab.
I love that, and I'm very much looking forward to, yes, your capabilities to give students that experience. Just I've experienced it. I've been hypoxic. I know what my symptoms are, and other people have different symptoms. And I think something that maybe people entering the aviation industry don't always know, but if you're going to go into flight training, you learn a lot about your body and how to, take care of yourself, but also recognize symptoms that maybe I'm not fit to fly right now, or maybe something is wrong in my environment. And really becoming attuned to that. A question that we get a lot, and I guess because it's, it's in the public conversation, and autonomous systems are just becoming, more and more ready around us. But do you see a future in aviation where the human component is entirely removed? Do you think that, just give us your opinion, when and how?
Yes. So the pilot shortage, it's a big deal in commercial industries. And by 2024, like 53K pilots, they are going to retire in the entire global aviation industry. And also with this pandemic, there are like many people, they walked out of flying, and also many people, they are not interested in flying to other countries and all that. So there are like many issues that are intertwined with the pilot shortage issue. So that's why Airbus, Boeing mainly, they were testing out single pilot operations. So there will be only one human in the cockpit with robotic arm as a co-pilot. So the human pilot will be pilot in command, and the robotic arm, it will be a second in command. So the Boeing tested out, and they were running some tests. But we did a research a couple of years ago on the consumer perception. So we surveyed public whether they would trust that type of system, and the public's our findings indicated that they were not okay with having a technology in cockpit. They need human intervention, and that's not going to go anytime soon. I mean, Boeing, they have to publish their test reports, how it's performing, to gain that public trust and acceptance. Then only I think it's possible. Maybe in 2025 we are going to have Uber taxis. So so some of them, they are autonomous, some of them they will have just one pilot in the cockpit, who knows. But whatever they are planning to do, whatever they are going to introduce in the industry, they need to gain public trust and acceptance. Otherwise, I don't think it's possible.
Thank you. Yeah, I know it's an interesting conversation, but for anyone viewing, just to know there are researchers like you who are working on those questions and understanding. The industry doesn't just head in a direction blindly. It has a lot of safety and a lot of research data backing it. All right. Well, I think we are just about out of time for questions. So I want to send a huge thank you to Dr. Tamilselvan and Dave for showing us the ASAPE lab today. And also a thank you to Donny and Jason for sharing time in this CRJ lab. Again, another thank you to our viewers for joining us. We hope that you did enjoy this virtual visit to another aspect of SLU's Aviation Science Department. So we were out of the hangar today and over on our main campus. If you would like to learn more about the aviation programs at SLU, you can go ahead and visit slu.edu/parks. And as always, feel free to reach out to us at our email address, parksevents@slu.edu. If you would like more information, or if you would like to connect further with us. For our teachers logged on today, we would be happy to set up a virtual lab visit or a guest speaker for your classroom this semester from one of our academic programs. Just send us an email and we'll get that scheduled. And we hope that everyone will join us again in this space next week for a visit to the Soft Tissue Engineering Lab and the Biomedical Engineering Program. And that will be on Friday, March 12th at 1 p.m. So this concludes our webinar today. Thank you again for joining us, and have a great rest of your week.